Hello, welcome back. We're on 2.2, page 3, which really the whole page focuses on a pretty simple but very important concept for us, and that being end model behavior. So let's take a look. On 23 to 28, we're going to use a graphing calculator to graph the functions f and g. So we will show those graphs. We're going to view them in the same viewing window. Zoom out far enough to see the right hand and left hand behavior of each graph. That's the end model behavior. Do the graphs of f and g have the same end model behavior? Explain why or why not. Okay, so 24. I have already entered these functions. And of course, I could put this 1/3 as a fraction, but division, fraction, same thing. So we've got the two functions. Some people get concerned with this, that maybe I should have the negative 1/3 in parentheses so the x cubed isn't in the denominator, but it's not. This is just negative 1 divided by 3 times x cubed. So let's go ahead and graph this thing. I'm going to zoom 6. That's zoom standard. And there's our first function. A little wiggling going on. And our second function should be coming. There it is. And I believe we got enough wiggling going on for a third degree polynomial to say that, yes, we've reached end model behavior. So just a rough sketch. I want to know that you participated with this and you did the due diligence of the graph, of graphing this on your calculator. It looks like we've got something along the lines of this, and then this one looks like it stays inside of the other, something like that. So there's our graph. Zoom far enough out to see the end model behavior. Do the graphs have the same? Yes, they have the same end model behavior. And explain why or why not. And the reason why is because f of x is negative 1/3 x cubed ... In other words, this is an odd degreed polynomial, and the biggest exponent is odd, and it's negative. Odd negatives fall to the right, fall to the left. And g of x is strictly negative 1/3 x cubed. They have the same end model behavior because they're what I refer to as the distance runners, the terms that are in control of what eventually happens. The further we get away from 0 in both directions, this negative 1/3 x cubed is going to start dominating the other terms after we distribute. So the answer to 26 should be pretty clear. This is even, positive, so it's going to rise in both directions. So the end model behavior for both of these is rise to the left, rise to the right. They're going to have the same end model behavior, but let's get the graphs. So we've got 3x to the 4th minus 6x, so that's a squared, and versus just 3x to the 4th. And let's see zoom standard, see if that'll work for us. There we have a little W kind of shape. And then we just have a sort of, it's truthfully not a parabola, but what we see is that both graphs rise to the right, fall to the left. Yes, they have the same end model behavior, and f of x is 3x to the 4th ... That's what's going to be in control, which means eventually it wants to rise to the right, rise to the left. And g of x is 3x to just 3x to the 4th. So pretty simple concept there. Sorry if that was a little bit low. Okay, 28. So f of x is, if I distribute this, this is negative x to the fourth plus 6x squared plus x minus 10 versus g of x is, of course, just x to the fourth. Well, they have the same end model behavior, even versus even, but upside down versus right side up. This graph is going to eventually fall to the left, fall to the right, where this one's going to rise and rise. But we'll look at it on our graphing calculator. So we have negative parentheses x to the fourth plus, oh, no, minus 6x squared minus x plus 10 versus just x to the fourth. And we should start with our upside down. It's got some wiggling going on. So we got a function looks sort of like comes up, comes down, levels out. This versus this. No, not the same end model behavior. That's because negative f of x is negative x to the fourth, dot, 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 but g of x is just positive x to the fourth. Okay, and this, truthfully, we could do without seeing the graphs, and that's what they have us do in the next section. Use the lead coefficient test to describe the right and left hand behavior of the graph to the polynomial function. So this is negative x to the sixth plus 1. This graph eventually wants to look like negative x to the sixth. Sure, at 0 it's up 1, but by time we get to negative x to the sixth takes over, it wants to go down to the left, down to the right. So we would say falls to the left and falls to the right. And I'm going to be very picky about this. We're going to use that preposition to. We're not going to say, all right, oh, by the way, you don't have to draw this graph, but just for explanation of why I'm picky. I don't want you to say it's rising from the left and falling to the right. I want it to be, what's it doing to the left, falling, what's it doing to the right, falling. And you're welcome to check those with your calculator, but I don't think that you necessarily need to. Now this graph is going to start looking like a steep line, like 5x, but eventually it's going to look like a positive cubic, rise to the right, fall to the left. So we would say it rises to the right, it's a positive third degree, rises to the right, and falls to the left. Okay, 34. If we were to write this out and divide through by 4, we would have 3/4. That's positive 3/4 x to the seventh, dot, dot, dot. This is odd, so it wants to rise one direction, fall the other. It's positive, so it rises to the right, but falls to the left. Rises to the right, falls to the left. And finally, 36, if we were to distribute, we would get negative 7/8 s cubed and that's our biggest exponent. This is third degree, so it's going to go up one way, down the other, but since it's negative, it falls to the right, rises to the left. Falls to the right, rises to the left. So there's a 10-minute video, but probably about a 6-minute assignment for you without explanation. But please make certain on 23 through 25 you are actually including the graphs with those. You do not have to check these on your calculator, but you may want to, just for confirmation. Let me know what I can help with.